In this video, we are going to study partial fractions. When we add algebraically 4 upon x minus 1 and 3 upon x plus 2, we get, which is 7x plus 5 upon x minus 1 into x plus 2. Here, 4 upon x minus 1 plus 3 upon x plus 2 are known as partial fractions of 7x plus 5 upon x minus 1 into x plus 2, and the process of obtaining partial fractions 4 upon x minus 1 plus 3 upon x plus 2 from 7x plus 5 upon x square plus x minus 2 is known as resolving rational function 7x plus 5 upon x square plus x minus 2 into its partial fractions 4 upon x minus 1 plus 3 upon x plus 2. Let us study more about this. Hello friends, you are watching YouTube channel Number Collage. This channel features videos on mathematical concepts. Effort has been made to explore the concepts through basic mathematical ideas. Hope you will like my effort. You can even check playlist of this channel. Perhaps you might find videos that you are looking for. Now we will actually found partial fractions of a rational function 7x plus 5 upon x square plus x minus 2. First, we will factorize the denominator. That will be x minus 1 into x plus 2. Now we will write 7x plus 5 upon x minus 1 into x plus 2 as some constant a upon this linear factor x minus 1 plus another unknown constant b upon second linear factor x plus 2. Remember, there will be as many unknown constants as there are linear factors in the denominator. Since there are two linear factors, we have considered two unknown constants a and b. This will be equals a into x plus 2 plus b into x minus 1 upon x minus 1 into x plus 2. By cancelling denominator from both sides, what we finally get is 7x plus 5 equals a into x plus 2 plus b into x minus 1. Now we will use elimination technique to find out unknown constants a and b. Now to eliminate b, we will put here x equals 1. So this statement 1 will become 7 into 1 plus 5 equals a into 1 plus 2 plus b into 0. That will be 3a equals 12, a equals 4. So here we got value of the first constant a, 4. Now for the second constant b, we will eliminate a. For that we will put from x plus 2, x equals minus 2. So expression 1 becomes 7 into minus 2 plus 5 equals a into 0 plus b into minus 2 minus 1. That will be minus 3b equals minus 9, b equals 3. So this is the value of the second constant. Now we will substitute these values of a and b in place of a and b here. So in place of a here we will write 4, and in place of b here we will write 3, and here we get the partial fractions 4 upon x minus 1 plus 3 upon x plus 2. Here, in order to get value of a, we have eliminated b, and next in order to get value of b, we have eliminated a. A rational function px upon qx can be resolved into partial fractions under following two conditions. Number 1, degree of polynomial function px in the numerator is less than or equal to degree of polynomial function qx in the denominator. Number 2, denominator qx can be factored. Partial fractions are used in integrating certain rational functions which otherwise cannot be integrated. They are also useful in determining Laplace transform, on which you can find a separate video in the playlist. Basically, there are three types of partial fractions which depend upon the nature of factors in the denominator qx. These types are when the denominator qx contains a. linear factors, b. repeated linear factors, and c. quadratic factors. In the first type, when the denominator contains linear factors, the expression is of the type px upon x minus a into x minus b, and form of the partial fraction is a upon x minus a plus b upon x minus b. We will solve an example of this type. Resolve into partial fractions x upon x square minus x minus 12. Here, degree of numerator is 1 less than that of the denominator. So we write this expression equals x upon factors of x square minus x minus 12, x plus 3 into x minus 4. This we write as a upon x plus 3 plus b upon x minus 4. This further will be x equals a into x minus 4 plus b into x plus 3. Now in order to eliminate b, we will put x equals minus 3. So this expression 1 will become minus 3 equals a into minus 3 minus 4 minus 7a, and that gives a equals 3 upon 7. Next, to eliminate a, we will put x equals 4. So this makes expression 1 as 4 equals b into 4 plus 3 7b, and this gives b equals 4 upon 7. Now in place of this a, we will substitute 3 upon 7, and in place of this b, we will substitute 4 upon 7. So the partial fractions become 3 upon 7 into x plus 3 plus 4 upon 7 into x minus 4. So these are required partial fractions. Resolve into partial fractions 2x square minus 9x minus 35 upon x plus 1 into x plus 2 into x plus 3. Since there are three linear factors in the denominator, we write this as a upon x plus 1 plus b upon x plus 2 plus c upon x plus 3. So this will be 2x square minus 9x minus 35 equals a into product of these two factors x plus 2 into x plus 3 plus b into product of these two factors x plus 1 into x plus 3 plus c into product of these two factors x plus 1 into x plus 2. Now to eliminate this c, we will put x equals minus 1. So x equals minus 1 gives 2 into minus 1 square minus 9 into minus 1 minus 35 equals a into minus 1 plus 2 into minus 1 plus 3. Because x plus 1 is 0, b will also get eliminated. This will be 2 plus 9 minus 35 equals a into 1 into 2 minus 24 equals 2a, a equals minus 12. Next we will eliminate this b, and for that we will put x equals minus 3. So x equals minus 3 gives 2 into minus 3 square minus 9 into minus 3 minus 35 equals x equals minus 3 also eliminates a. So c into minus 3 plus 1 into minus 3 plus 2. This will be 18 plus 27 minus 35 equals c into 2. So 2c will be 10, c equals 5. Finally, to eliminate a, we will put x equals minus 2. So x equals minus 2 gives 2 into minus 2 square minus 9 into minus 2 minus 35 equals b into minus 2 plus 1 into minus 2 plus 3. Because of x equals minus 2, c will also get eliminated. So this will be 8 plus 18 minus 35 equals minus b. So this gives b equals 9. Now we will replace this a by this minus 12, then this b by this 9, and finally this c by this 5, and we get these partial fractions. Resolve into partial fractions x square plus 1 upon x square minus 3x plus 2. Here degree of numerator is 2 and degree of denominator is also 2. So we will perform long division to find quotient and remainder if any. Divisor x square minus 3x plus 2. Dividend x square plus 1. Dividing this x square by this x square, we get 1. Multiplying x square minus 3x plus 2 by 1, we get x square plus 2 minus 3x. After changing signs, this will be 0 minus 1 plus 3x. So here we have quotient equals 1 and remainder 3x minus 1. So by division algorithm, we write dividend x square plus 1 equals quotient 1 plus remainder 3x minus 1 upon divisor x square minus 3x plus 2. We name this 1. Now this rational function where degree of numerator is 1 less than that of the denominator is a perfect case for finding partial fractions. So now we will find partial fractions of 3x minus 1 upon factorizing x square minus 3x plus 2. Its factors will be x minus 2 into x minus 1. That we write as a upon x minus 2 plus b upon x minus 1. So this gives 3x minus 1 equals a into x minus 1 plus b into x minus 2. Now in order to eliminate b, we will put x equals 2. That gives 3 into 2 minus 1 equals a into 2 minus 1. That gives a equals 6 minus 1, 5. Next, to eliminate a, we will put x equals 1. That gives 3 into 1 minus 1 equals b into 1 minus 2 minus b will be 2, b equals minus 2. Now to write the partial fractions, we will replace this a by this 5 and this b by this minus 2. So the partial fractions will be 5 upon x minus 2 minus 2 upon x minus 1. Resolve into partial fractions the rational function x cubed minus 2x square minus 4x minus 4 upon x square plus x minus 2. Here degree of numerator n, which is 3, is greater than degree of denominator, which is 2. So therefore we have to carry out long division. So divisor x square plus x minus 2, dividend x cube minus 2x square minus 4x minus 4. First we divide this x cube by this x square to get quotient x that we write here. After that we multiply x square plus x minus 2 by x and write below x cube plus x square minus 2x. We change the signs, 0 minus 3x square minus 2x. Then we pull down this minus 4. Next we divide this minus 3x square by this x square again, giving us quotient minus 3 that we write here. Now multiplying x square plus x minus 2 by this minus 3, we get minus 3x square minus 3x plus 6. We change the signs, 0 plus x minus 10. So we have quotient here x minus 3, remainder here x minus 10. So now the given rational function becomes quotient x minus 3 plus remainder x minus 10 upon divisor x square plus x minus 2. Now this part is a perfect case for finding partial fractions because here degree of numerator is 1 less than that of the denominator. We will write this as x minus 10 upon factors of x square plus x minus 2, x plus 2, x minus 1. This we write as a upon linear factor x plus 2 plus b upon second linear factor x minus 1. So we have x minus 10 equals a into x minus 1 plus b into x plus 2. In order to eliminate b, we will put x equals minus 2. So that gives minus 2 minus 10 equals a into minus 2 minus 1 minus 3a. So a will be 4. Next, to eliminate a, we will put x equals 1. That gives 1 minus 10 equals b into 1 plus 2, 3b. So b will be minus 3. Now we substitute this a by this 4 and replace this b by this minus 3. So these are partial fractions along with this linear function x minus 3. Viewers, if you like this video, please click the like button. Share this video with your friends and classmates. Subscribe to this channel. Post your constructive comments to make the videos better. You can even check playlist of this channel. Perhaps you might find videos that you are looking for. See you in the next video. Until then, keep watching Number Collage. Thank you.